This video is designed to explore how to transfer our understanding of sine and cosine on the unit circle and on circles of radius not equal to 1 into working with right triangles without the circle at all. And you can go back and forth between working with a triangle and those acute angles and the right angle, and then working on a circle. So let's start with sort of where we ended on that other video, that if you are landing someplace, and I'll just put it in the first quadrant for convenience, but if you're landing someplace and you've got an ordered pair, x comma y, and you're not necessarily on the unit circle, so that this is radius r, that the x is r cosine theta, and the y is r sine theta. So that as you drop this down, make a right triangle out of it. Here's your radius r, and here is the side r sine theta, because that's the y coordinate, and here is r cosine theta, because that's your x coordinate. So I'm going to play around with that a little bit and try to see how can we start. Just let me write it over here where there's more room. So this is just kind of a triangle that you've gotten off of the unit circle. It's a bit in general. So this one is r sine theta, and this one is r cosine theta. Here's the right angle. Here is the origin, and here is the ordered pair, if you want to imagine that circle of radius r sort of surrounding this, but you don't really need it. So what I'm going to do is I'm going to say, okay, all right, so this is one of the legs of this triangle, and here's another leg of this triangle, and here's the hypotenuse. So one thing that we know for sure is that we could solve this for cosine of theta and solve this one for sine of theta. So here, cosine of theta, divide by the r, that's b over r, and sine of theta is a over r. Another thing we know is that a squared plus b squared equals c squared. So we know that r sine theta squared plus r cosine theta squared equals r squared. And this one's kind of interesting, because you go, okay, so r sine theta squared, that's r times r, that's r squared. Sine squared theta, sine times sine is sine squared. Again, r squared, this time cosine squared, equals r squared. But divide both sides of this equation by r squared, and all you're left with is the Pythagorean identity, sine squared plus cosine squared equals r squared divided by r squared, 1. Okay, so that's a bunch of information that the sine is kind of this side. So here's the angle, remember. There's the theta. Let's go back to the original picture. There's the theta. There's the theta that got you this x and y coordinate. Oops, went too far. So interesting. So the sine of theta is this side, this leg over here, over the hypotenuse. And the cosine of theta is this side over here, over the hypotenuse. So there's a mnemonic that can help us with this. So let me draw the triangle again, kind of shrunk because I don't have much space. But this time label these, and that's terrible. Doesn't it all look like the same shape? There we go, that's a little bit better. Let me label these sides instead of R or C or A or B or whatever. I'm just going to call this the hypotenuse. Here's theta. This is the side opposite theta. Here's the side adjacent to theta. So where we said that sine theta is A over R, now we can say it's the opposite over the hypotenuse. So sine of theta is the opposite over the hypotenuse. Let me write that down. Sine of theta, and I'm in some right triangle. Here's the hypotenuse. Here's the side opposite the angle theta. Here's the side adjacent, so right next to the angle theta. And we just said that sine is this opposite side over the hypotenuse. Let's check that. Yeah, sine is the side opposite theta over the hypotenuse. Okay, and cosine is the side adjacent over the hypotenuse. The cosine of theta is the side adjacent to the angle over the hypotenuse. As a mnemonic, so, S-O-H, CAH, C-A-H. And we'll add to that mnemonic in a little bit, but SOHCAH. Any right triangle, sine is the opposite over the hypotenuse, and the cosine is the adjacent over the hypotenuse. I'm going to give an example of that in another video soon.